All right, guys, we're doing lesson 4 here in the similarity unit. I'm going to try to make this as balanced as possible, but I left my stand that I would video with at school, and obviously we're not allowed to get in there. So I'm going to do the best I can. So if it's a little wobbly, just bear with me. I'm getting another one shipped to my house, so the future one should be a little bit better. This is Mrs. DeFreya. We are kind of all rotating and doing videos as best we can. I have my kids downstairs, so I'm hiding in my son's room using a tray as my desk. All right, so here we go. For your do now, they want to know, are the triangles similar? And justify your answer. So what I would suggest doing is finding the missing sides, or I'm sorry, the missing angles for each of the triangles so that you can kind of make sure that they are similar. I definitely see this angle is congruent to this angle, right? So angle B is congruent to angle E, but we know that when we have similar triangles, all of the angles have to be equal to each other, right? So kind of right here and right here is a hint that they aren't. But with that said, no harm in finding out the missing angles, okay? So if I add together 95 and 25, I'm gonna get 120. And then 180 minus 120 is gonna give me 60, right? So this angle right here is 60 degrees. When I add together my 95 and my 24, I'm getting 119. So 180 minus 119 is going to give me 61 degrees. So this one right here is 61 degrees. So are they similar? We're going to say no, because not all angles are congruent. Okay, we know that when we have similar triangles from earlier lessons, that we should have all of the angles preserved when we have similar triangles, right? So this one, no good. Okay, did I actually have to find the missing angle right here and right here? No, it definitely was a hint that these guys didn't match up, so automatically I can tell that they would not have been similar. Okay, so that leads us down to the notes down at the bottom. If two angles of one triangle are congruent, the corresponding angles in the other triangle are similar. I don't know if I read that completely appropriately. If two angles of one triangle are congruent to the corresponding angles in another triangle, then the triangles are similar. Because if I would have added together these two and subtracted from 180, that would have been matched that, right? Because these guys are congruent, right? So if I would have added these together and subtracted from 180, this angle and this angle would be congruent. So that means that all of the angles inside of the triangles are congruent. Okay, so if angle D is angle A and angle D are congruent, angle B and angle E are congruent, then this triangle and this triangle are similar. Make sure we know the proper symbol for similar. It's just that little squiggly that we got there without the equal sign underneath. The equal sign would mean that they are congruent. Okay. So we're going to do some basic proofs in this chapter to prove similarity. Okay, when we have this symbol right here, that means parallel, right? So just in case, let's label. Whenever we do a proof, we want to make sure that the first thing we always write is the given. So we have AB is parallel to DE. And the first thing I think of, let me just give our reason. That's a given. It might be nice and easy to separate that there. The first thing I always think of when we have parallel lines are our Z's, right? Our Z's represent alternate interior angles, right? So I can have a Z going forward. So that means this angle is congruent to this angle, but put a little 1 and a little 2 in there. Just helps me out for when I'm writing out my given, or for when I'm writing out my statement and reasons. And then I have a Z going backwards. So I have a forward Z and a backward Z. This angle is now going to be congruent to this angle. Oops, that should be a 4. My apologies. Okay, so far so good, hopefully. All right, so for that, they're going to be congruent for the same reason, because alternate interior angles, right? We have parallel lines form congruent alternate interior angles. So I'm going to do step 2 right here. Angle 1 is congruent to angle 2. Separately, I'm going to have that angle 3 is congruent to angle 4. I can put them in the same statement and reason though, because they're going to be because of the same reason. But notice that I didn't say that angle 1 is congruent to angle 2, congruent to angle 3, congruent to angle 4. That's not correct. Okay, and my reason is because parallel, right? We getting this from the parallel lines right here. So I have to utilize that in my reason here. Parallel lines form congruent alternate interior angles. Okay, when we're proving, we're not proving congruent, so I don't need 3 pieces. When I'm proving similarity, I just need to prove that 2 angles are congruent. Okay, there are other ways, but in this particular scenario, we're doing our angle practice. So I'm going to say that triangle ACB is similar to triangle ECD, and I'm getting that just from the proof. I've done enough to prove it. So in step 3, I'm going to say that triangle ACB is similar to triangle ECD, and my reason is from the prior page, angle. I just have to do my AA. This says that I have a set of congruent angles and another set of congruent angles that are corresponding with one another, and that is accurate. Okay, example 2, the triangles shown are similar. It might be on the next page here, sorry. My printer kind of got it all messed up, so it's at the top there. Use proportions to find the missing lengths of X and Y. Okay, so that's, I'm just going to move this page on over, but we're looking to find the length of X and the length of Y. All right, so I got this right here. So this piece is corresponding to this piece right here, and then this piece is going to be corresponding to this piece right here. So I'm going to go from 4 to 12. So if I'm starting from my 4 going to the 12, I need to start at my X and go down to my 16.5. Okay, so when I make my proportion, it's going to be 4 over 12. Okay, circle to arrow, circle to arrow. You always have to go in the same direction. Make sure you put your equal sign in between there. I know a lot of us just kind of get a little lazy there and just don't put the equal sign. It's not a proportion without the equal sign. Okay, so we're going to go ahead and do our cross multiplication. Remember, that's diagonal. Okay, so I'm just going to type it in, 16.5 times, times, clear, 16.5 times 4. I'm getting 66 up here, and I'm getting 12x over here. I'm going to set up my, so 12x equals 66. 66 divided by 12, I believe, is 5.5. Okay. And that's my answer there for my X. Okay. I'm going to do my other proportion to find out what my Y is. So I'm going to stick with my 4 to 12 because that was given information. So that means I'm going to go, so my small to big, I'm going to do 3.14 to my Y. Okay. So I'm going to go always from my circle to my arrow. Okay, circle to arrow, circle to arrow. So I'm going to set up my proportion over here, 4 to 12, and then 3.14 to y. And again, the same process here. You guys are really good at solving proportions. So I'll cross multiply here is going to get me my 4y. And I'll cross multiply here. I get 12 times 3.14. It's going to give me 37.68. And I'll divide that by 4. Is 9.42. All right. So we found our x and we found our y. Example 3. This is the last example. They are telling us in here that we have similar triangles. So I know that I have sets of congruent angles. D is on AC. So they're telling me, sorry, so ABC. So this big triangle here is similar to this little triangle here. And if you notice, they're sharing a vertex, right? So if I were to separate them, angle C is in common for both triangles, right? For my pink triangle and for my blue triangle. D is on AC and E is on CB, such that the two lines are parallel, right? So I have DE is parallel to AB. They're telling me that CD is 5. I'll use pink for that one. So CD is 5, that little guy right there. And they're also telling me that AD is 10. I'm going to use purple for that one. I'll show you why in a moment. So AD is 10. That means that the whole side from here to here is 15 for that whole triangle, right? This is not part of the triangle. Please make sure you realize that. Okay, they're giving you that so you can add these pieces together to know that the whole side AC in the blue triangle is 15. You have to just kind of be able to put those pieces together. And the other thing that they're telling you is that AB is 18. So that is a blue piece, right? Because that's part of my blue triangle. We're trying to figure out the side, the missing length of DE. And I'm going to use pink for my pink triangle. I'm going to put an X right there to try to figure that out. They're already telling you that they're similar, so you know a bunch of things. You know that you have corresponding angles are congruent. You also know that the sides are in proportion. Okay, so you can just go ahead and set up a proportion here. I'm going to go pink to blue, pink to blue. Okay, what you guys need to realize is a lot of you are going to mess up and do 5 to 10 and then X to 18. Okay, they're giving you that 10 so you can figure out that 15. That's where the biggest mistake is going to lie for you guys. All right, so let's go ahead. 5 over 15. And there's a lot of correct proportions. If you used a different proportion, that's okay. X to 18. All right, as long as when you cross multiply, you're getting a 15x and a 90. Okay, I got the 15x by cross multiplying here. I got the 90 by cross multiplying here. I'm going to divide by 15 on both sides, and I'm getting 1, 2, 3, 4, 5, 6. Okay, so I answered my question. DE equals 6. Done and done. All right, guys, so you have an independent practice question here. They're telling you that the triangles are similar. Okay, they want you to find all of the unknown angles. So you should be able to line up where the 15 goes. Just realize that this one's rotated here, right? So if you were to turn that around, which angles are going to line up with one another? right? So I believe that angle B and angle E are going to line up with one another. It should be a little hint right there. So this angle and this angle line up with one another. Don't forget, similar triangles have congruent angles, right? So when they're dilated, the angle measures are preserved, right? That means they stay the same. They want you to use proportions. So you're going to use two different proportions to find the length of AC, and you're going to do a separate proportion to figure out the length of EF. May I suggest you put an X right here and a Y right here. Don't use the same variable because you're finding two different lengths. I hope that's helpful, and message your teacher if you have any questions. Take care, guys. Bye-bye.